Hello everybody, it's Miss Fincham and we'll be continuing and finishing our Unit 1 notes today by covering the topic 4.9, which is a really interesting environmental phenomenon called the El Nino Southern Oscillation. This is a periodic shift in atmospheric pressure, wind patterns, and ocean temperatures in the South Pacific. It's a cool way to end this unit because it builds on a lot of the other topics from Unit 1. Thank you to Jordan Smeeds for the slides and notes we use in class. Our objective for the day is to be able to describe the environmental changes and effects of El Nino and La Nina events, which are the two extremes of the Southern Oscillation pattern. In order to do that, we need to know that these events involve changes in the Pacific Ocean surface temperature, global wind patterns, and ocean currents. We also need to understand that they are influenced by geological and geographical factors, and that they have different environmental impacts on different areas. Our suggested science skill for today is to describe environmental problems. Before we get into El Nino and La Nina, we have to look at some global ocean surface current patterns, and the first thing we will discuss here is a gyre. A gyre is a large ocean circulation pattern that happens because of global wind patterns. In the northern hemisphere, they are going to be clockwise, whereas in the southern hemisphere, they are going to be counterclockwise. Let's take a look at how global wind patterns cause these gyres to form. If we look on the map here, we'll see that between 0 and 30 degrees, wind patterns are going to be moving along the equator from east to west. Whereas when we get up to 30 degrees, so between the 30 and 60 degree mark, we're going to have westerlies, which are going to blow these ocean surface waters from west to east. We get these predictable patterns of clockwise rotation or surface currents in the northern hemisphere and the counterclockwise rotation in the southern hemisphere. Again, that's based on the prevailing wind patterns that are going to move ocean surface waters along the equator from east to west. Then they are going to switch to move northward. They get directed by bodies of land. Then they get to 30 degrees where they switch directions from west to east, and they're just repeating these cycles every 30 degrees. Another important topic we're going to talk about here is upwelling. If we look at the shaded dark blue areas along the coasts of different continents, we will see upwelling zones. These are areas where we have warm surface waters that are moving away from a landmass. The Peru current shows warm surface water moving away from the coast of South America. And the California current is moving water from the coast of North America. And what this does is it brings colder water up from lower in the ocean to replace that warm surface water. The benefit of upwellings is that it brings up oxygen because cold water holds more oxygen than warmer water. It also brings up sediments from deep in the ocean, which have nutrients. Along these upwelling zones, we are going to see really productive fisheries. These are really productive fish populations where people will often make sources of income by catching the fish or have sources of food. Before we move on, there's one final thing here I want to call your attention to on this slide, and that's this region of the Southern Pacific here. This area outlined in yellow is where we'll be focusing today, so I want you to remember that during normal conditions, we have eastern trade winds that are blowing these surface waters from east to west. This is going to move warm surface waters over towards Southeast Asia and Australia, and it's going to lead to this upwelling, which brings cooler water up to the coast of the Americas. That upwelling is going to be really important to understand when we go forward to discuss what happens during an El Nino and La Nina event. All the currents in the ocean are connected and help mix the oceans across the globe. The thermohaline circulation is this movement of ocean currents that connects all of the world's oceans and mixes salts, nutrients, and temperature throughout all of them. So as we discussed in the last slide, warm surface water moves east to west along the equator and then up into the Gulf of Mexico where it warms further. As it gets up to the 30-degree latitude, it's going to be blown from west to east by the westerlies. So as it moves back towards Europe, it is channeled up towards the North Pole. This warm Gulf Stream flows north, allowing some of the water to evaporate, making it more salty since the salt cannot evaporate with the water. It also cools and becomes more dense so that by the time it reaches the North Pole, it is much more dense due to both temperature and increased salt concentration. This causes it to sink. If you look at the diagram on step 2, we're switching from a red arrow to a blue arrow to signify that this water has sunk down to the ocean floor, where it's going to mix around and spread out all over. This is important because it distributes the salts in the ocean and the sediments, which have nutrients, and even mixes the temperature of the ocean. What happens though is eventually this cold, deep water is going to have to come back up to the surface, especially at these upwelling zones where it's going to replace the warmer water that is being blown away from a landmass. This is going to bring up colder temperatures, nutrients, and oxygen with it, and again, it just contributes to this global mixing of the world's oceans. The thermohaline circulation also has an important implication in moderating the temperature of different areas of the Earth. If we look at step 1, here where this warm water from the Gulf of Mexico is moving northward, and then it starts getting blown from west to east by the westerlies, and moves up past Europe, it's going to bring some of this warm air that it is carrying and deposit it over Europe, which is going to make the climate of Europe far warmer and much more moderate than climates at the same latitude that we find over in Canada. This is one way that this thermohaline circulation has an important effect on the climate of different regions. With the basics of global ocean circulation down, we can move on to the ENSO, or the El Nino Southern Oscillation. There is the tendency to simplify this concept into just an El Nino or La Nina event or normal conditions, but it is called the Southern Oscillation for a reason. As we can see in the graph, what we really have is a constant fluctuation or oscillation back and forth between El Nino conditions, which bring warmer, rainier conditions to South America, and La Nina conditions, which bring cooler, drier conditions to South America. I also want to point out that El Nino and La Nina events don't usually just solely occur in one year, so we call them events because they might peak in a given year, but they usually grow and then weaken over the course of a few years. Before we talk about an El Nino or La Nina event, I just want to review the conditions that happen during a normal year or during the normal conditions. Normally we have trade winds that are going to blow from east to west in the equatorial region, and this is going to move the warm surface water of the oceans towards the west. It is going to shift it towards Australia and Southeast Asia, and because warmer water and warmer air, which has more moisture, it's going to lead to higher precipitation in this region, which also pulls cooler water up from the depths of the ocean to replace this warm surface water, and we can see that upwelling effect here with the warm surface waters blown from east to west by the eastern trade winds. It is going to pull colder water up to replace the warmer water that is moving away. Remember, colder water holds more oxygen. It also brings up sediments which have nutrients. This is why the coast of South America here is going to experience really productive fisheries during normal or neutral conditions, because we have this warm air mass over here that is going to be rising and expanding, and this is going to create a low pressure system in the west, and that air is going to expand and sink back down and create a high pressure system over in the Americas, and which continues to drive these trade winds in the east to west direction. Now we'll look at the El Nino event. The major indicator of an El Nino event is that the trade winds are weakening and they are actually going to reverse their direction. So they are no longer blowing from east to west, but they are going from west to east. What this does is it shifts the concentration of warm surface waters towards the Americas. This means we're going to have cooler than normal conditions in Australia and Southeast Asia, and because of that, there is less rain. This means we are actually going to see drought-like conditions potentially in Australia and Southeast Asia. This warmer water being shifted towards the Americas gives us milder winters in North America, but it also is going to lead to much rainier and warmer weather in the Americas, which can lead to flooding. And the big problem, especially in South America, is that it's going to suppress the upwelling. Notice that with this warm mass of surface water, we do not have the upwelling of this cold, deeper ocean water, and that is going to be a problem. It is going to really shut down those productive fisheries, and it's going to be really harmful to people that rely on fishing as a source of income or food, especially along the coast of South America. Lastly, we will look at La Nina conditions. La Nina conditions are going to be stronger than normal trade winds, so this sees a reversal of the trade winds back to our east and west direction, and that is going to shift the warmer surface waters back over to Australia and Southeast Asia. It's going to lead to even warmer than normal conditions there and even rainier than normal conditions. This means we may see flooding and more intense monsoon activity in Southeast Asia. This will lead to increased upwelling off the coast of South America. So in the Americas, we are going to see cooler than normal weather, meaning there will be less rain and less precipitation than average, and we're going to see especially productive fisheries due to this increased upwelling effect. To summarize the effects that El Nino and La Nina can have on different regions, the really important takeaway from El Nino is that it brings warmer surface water to the west coast of the Americas, and that suppresses the upwelling of cold, deeper ocean water, especially in South America, which can be devastating for fishermen who depend on the productive fisheries and for farmers who will often lose crops due to the flooding that's brought on by the especially rainy El Nino season. Farmers in Southeast Asia and Australia, meanwhile, may experience droughts due to the decreased rainfall that they see as the warmer Pacific waters are blown away from them and towards the Americas. Two positive impacts of El Nino, however, are that they typically weaken hurricane activity in the Atlantic, and they typically weaken monsoon activity in India and Southeast Asia. This also leads to typically a warmer, more mild winter in North America. La Nina, on the other hand, brings especially cold weather to the west coast of the Americas. This can lead to less precipitation in the Americas and can also increase tornado severity in the U.S. and hurricane activity in the Atlantic. Southeast Asia can return to the rainy conditions they are used to, which can be beneficial for agriculture, but it can also bring extreme flooding and an extreme increase in monsoon activity. These next 3 slides, I did find a concise summary that neatly pictured what happened during an El Nino and a La Nina event, as well as during neutral conditions. I have included these in your case study 1C in case you would like to color the water temperature difference between the 3 for your test next week. This first slide is La Nina conditions, the next slide is neutral conditions, and the last slide is El Nino conditions. I know that it helped me to visualize a little bit better what was happening in each event. Our practice FRQ for topic 4.9 is to describe an event problem. I would like you to describe 2 environmental problems related to the conditions of an El Nino event. Once you have done that, please take pictures of your notes and turn them in on Canvas. You have finished all of Unit 1's notes. Yay!